Assalamu alaikum. I am Dr. Saeed Ali Mardan Admi. Welcome to my channel. In this lecture, we will learn how we can evaluate triple iterated integrals. For this purpose, we will learn exercise 15.5, question number 9 from Thomas Calculus 12th edition book. In this question, the statement of problem is we have the limits 1 to e, 1 to e square, 1 to e cube, where e is the exponential function, and we have to integrate 1 over x by z for the variable dx, dy, dz. Please note that in triple integrals, we have three kind of variables. This x, whose limits are 1 to e cube, is called the inner variable. Second, y, whose limits are 1 to e square, is called central variable. And the third, z, whose limits are 1 to e, is called outer variable. We always start our process of integration from most inner variable, and then on the outcomes of integration of most inner variable, we will apply rules of integration with respect to central variable. And then on the outcomes of integration of function with respect to central variable, we will apply rules of integration on the outer variables. So we will start integrating with respect to x, then with respect to y, and then with respect to d, inner to outer. After this, please also remember that limits of inner and central variables may be constant or may be in the form of variable or a mixture of them, but limit of outer variable is always in the form of real numbers. Means the limit of outer variable is always constant. After this, before solving this particular question, let's have a revision from calculus 1 or single variable calculus. If we have to integrate this function 3x plus 5 with respect to x, how we will integrate it? In this function, we have two kinds of constants. First constant is 3 and second constant is 5. First constant 3 is being multiplied with x, whereas the constant 5 is being added in the function 3x. So how we will deal them? The constant which is being multiplied with a variable term remain as it is, and we will apply rules of integration on the variable term as 3x square over 2. Plus, if we don't have any variable term with the constant, then we will integrate it as 5x, means we will associate the variable with respect to which we are performing the integration, and plus the constant of integration. And one more important formula we need in this question is integral of f prime of x over f of x gx is equal to natural log of f of x plus c. What it means, if we have a fraction and derivative of denominator is available in the numerator, then the integration of such fraction is natural log of denominator plus c constant of integration if we have indefinite integrals. Now, let's see what happened here. Please note that in multivariable calculus, when you are performing integration or derivative with respect to one variable, all other variables will behave like constants. So in this function 1 over x, y, z, 1 over y, z is being multiplied with 1 over x is constant with respect to x. So in the first step, I have separated 1 over y, z from 1 over x. In the next step, I'm going to perform the integration. So in the process of integration, 1 over y, z remain as it is, and I will apply rules of integration on 1 over x, just like 3x. Here, in this question, 1 over y, z will behave like 3. So integration of 1 over x is natural log of x. So in the next step, I have performed the integration. 1 over y, z remain as it is. Integration of 1 over x is natural log of x for the limits 1 to e cube. After this, I will apply limits, upper limit minus lower limit, with the help of fundamental theorem of calculus. So I have natural log of e cube minus natural log of 1. When we apply the limits, we will replace variable with upper limits. Minus is a sign of formula of fundamental theorem of calculus, and then we will replace our variable with lower limit. In the next step, natural log of e, natural log and e is the exponential function, are the reciprocal of each other. They will cancel out each other, and we are left with 3 in the first term. Natural log of 1 is 0. So from this bracket, we have only 3. You can take this 3 outside of the integral because it is constant. And in the next step, we will perform integration with respect to our central variable y. Again, with respect to y, 1 over z is constant, so we can split it. 1 over yz is split it as 1 over z into 1 over y. In the next step, we will perform the integration of 1 over y with natural log of y, and 1 over z remain as it is. For now, after integrating, I will apply limits from 1 to e square, upper limit minus lower limit, following the similar process as for inner variable. Then natural log and e are reciprocal of each other. They will cancel out each other, and we will left with 2 in the first term, and natural log of 1 is 0. So we have integral is equal to 3 limits from 1 to e 1 over the 2 minus 0. This 2 is constant. You can take it outside. It is being multiplied with 3, and we get 6. And in the integration of z, 1 over z, the integration of 1 over z is natural log of z for the limits 1 to e. In the next step, we will apply the limits following the similar procedure. This is not. This is 1. So, sorry for the interruption. Natural log of e minus natural log of 1. Natural log of e is 1 and natural log of 1 is 0. So we have integral is equal to 6. Thank you so much for watching this video. I hope this question is clear to you. Please like and share this content with your friends. Allah Hafiz.